Thank you very much for being around still for lesson 4, inequality in the age and death. What we have looked so far at is rather a perspective on life expectancy. This is a mean value, statisticians call also an expected value, so an average in the population. But maybe it's also interesting at inequality in the age and death. And this is what we will cover now in lesson 4 after looking at the trend on the average in the past 3 lessons. What we have seen so far is that the development of mortality survival has been by and large a success story. Yes, there are deviating examples like Russia for many years. In recent years, life expectancy in the United States hasn't been really a success story, but if we look at it on a global level or also looking at high income countries, it's been definitely a success story. But even if you're not a statistician, maybe you have heard of this sentence, this saying, the mean is not the message. So what we want to ask now is, what about the variation in the age and death? Not only the mean, so there's many possibilities. You can have an average where you have a uniform distribution, so the same number of people dies at each age, or you can have the opposite, that everyone dies at the same age. Of course, this is not possible. Neither is possible, obviously. But so where is reality and why is this important? If everyone dies at the same age, you can also look at entropy as some kind of measurement for uncertainty. If you have that same number of deaths at each age, you would have maximum uncertainty about your length of life, your duration. If everyone dies exactly at the same age 85, this is, of course, not possible, but this would mean that you can rather plan your life. It's rather unlikely, or it's impossible in this hypothetical case that you die at the younger age, and it's also impossible that you die at an older age. So you can plan specifically for an age of 85 or 90 years. Obviously, this is not possible, but let's look at the development. And now I picked another country, England and Wales, since the year 1900. And how can you look at the variation in the age and death? Statisticians call it the density, and demographers and maybe other disciplines would call it the distribution of death. And over age, so we have age here on the x-axis, and on the y-axis, we have the density of death, so the numbers of death at a certain age. And as I said before, demographers use a radix of 100,000. So this radix of 100,000 means, like, if you follow the red curve, this is the year 1900, if you sum up all the values, you would have 100,000 deaths. And what you see in the year 1900, more than 10%, because that's 10,000 people, infants, died at age 0, so at their infant age. This has declined over time, thankfully, that infant mortality is not the age anymore which has the most deaths in the population. But please have a look, we have the year 1950 in England and Wales. It was still the age with the highest number of deaths, with 5%, and maybe you're familiar nowadays with the probability of dying for infants. In many countries, this is thankfully still maybe too much, 3 per 1,000, but this has been a huge reduction. We have seen in the 19th century values of 30% of death happening for infants. We see still here the curve, maybe 1950, 1960, we have not 30,000, but 3,000. And now we have improved the situation in many countries of the world. I say again, we, the royal we. I didn't do it, I'm witnessing it, and I'm excited about the actual progress we observe. It's not a reduction by something. 3,000 to 300 is an order of magnitude further improvement. So this is fantastic. Sorry, I had to say this because I think this is really one of the most fantastic developments we can observe, that those who were just born, who cannot do anything detrimental to their health themselves, that the situation, the survival situation has improved so dramatically for infants. if we look at later ages and if we do not look at infant and childhood ages, we have seen here is the mode, the highest number of deaths apart from infant and childhood has been about 70 for those who have survived infant and childhood. And this is slightly shifting to the right, but we cannot only see a shift to the right, but we also see a concentration. So the ages of death, if you look at the red curve here and maybe this kind of blue curve there, we see also concentration, not just to a single point, but we see a concentration, which means that people are actually also more able to plan their own lives. The probability for them to survive until a certain age has improved dramatically. We have seen a decline in the variation and what's called now a shifting mortality hypothesis. The decline in the variation is not so pronounced anymore, but it's shifting to the right-hand side. That's what we see for the most recent year, 2019. So it's still concentrated, but it's shifting further and further to the right. What does this mean again? It means, number one, compared to 50, 70, 80 years ago, individuals can expect more that they will reach a high age, and this age which they will reach is also increasing at the time. And if you survive, maybe this is an interesting perspective. The most common age at death, you know that life expectancy values for women are about maybe 82, 83 years for women. But if you look at the modal age at death, so the most common age at death, this is much higher. Why is this maybe interesting? If you look into the newspaper and only look at the age at death, and this is the age at death distribution, the values will be automatically much higher than life expectancy. So don't be confused by that. So this is the most common age at death. How can we measure this variation, the concentration in the age at death? Economists and maybe people also from other disciplines are familiar with the Gini index by Corrado Gini, also a demographer and an economist, that this is a measure of concentration. The most common measure nowadays in demography has become E-dagger. I know this is an equation, and there's this saying you lose about 10% of your audience by every equation. I hope I will not lose the audience because it's not so difficult, even if it looks difficult at first. E is remaining life expectancy at age X, and F is the density. So it means if someone dies at age 0 and life expectancy is 85 years, that person loses 85 years. If someone dies at age 80 and their remaining life expectancy is 10 years, then they lose 10 years. And so this is weighted by the number of people who actually die at a certain age. So what you measure is how many, the average number of life years lost is the kind of official definition. Or you could also say, how many years of life do you die ahead of your time? So if you die at age 80 and remaining life expectancy is 10, then you have lost 10 years of expected life. And it's always positive, I have to stress, because sometimes if you see that people read a life expectancy value of 83 and they see there's someone who's 90 years old, that person is not overdue, please. This person has still a positive remaining expectation for their life. So you're not minus 7 years, or you can also say it differently, like the famous demographer Nathan Keefe said, everyone dies prematurely. So you still have a positive rest length of your life. You're never in the minus here. And this is what's measured by this E-dagger. This is a symbol introduced by my mentor, doctoral father Jim Vopel, because it measures or should signify, symbolize death somehow. Looking again at England and Wales separately now for women and men, this kind of measurement for lifespan disparity, E-dagger. So how many years of life have you lost on average? In 1900, people lost about 23 years of life on average. So they died 23 years ahead of their lives. And nowadays, this has been going down to about 10 years of life. Maybe still too much, but number one, it means that persons can expect, plan more on average. Of course, there's always exceptions, that they will reach an old age. And number two, what I want to emphasize, a value of 0 is not possible, because that would mean that everyone dies exactly at the same age, and we cannot reasonably expect this kind of determinism, obviously. Let's look not only at England and Wales, but at all the 30-something countries from the Human Mortality Database, and let's plot on the x-axis life expectancy, and on the y-axis lifespan disparity. So the average length of life and the disparity associated with it. So the value here would mean that in this country and for the given year, life expectancy was 27 years. So this is probably a catastrophic pandemic year. Let's use something different. We have life expectancy here of 42 years for men, and they died about 21, 22 years ahead of their time. What's exciting, at least for a demographer, is this kind of downward slope, rather linear downward slope. What you can see is that the countries with the highest life expectancy have also at the same time the lowest or rather low lifespan disparity. In my opinion, this is rather surprising. When I looked at it for the first time around 2010, I would have expected something different. Why? I would have assumed that countries where there's some kind of vanguard, some people who are extremely long-lived, they are pulling out the frontier of longevity, of survival, and then others try to catch up. But initially, you would see some kind of not squeeze, what we see here, but rather some kind of prolongation. But this is not the case for most of the coverage of the Human Mortality Database. Long life and low lifespan disparity are extremely, extremely closely correlated. So it pays for a country to have not only high life expectancy, this is only achievable if lifespan disparity is rather minimal. I thought that's a very, very important message also for the individuals and for planners, politicians in various countries. And that's the end of lesson 4. I hope I was able to introduce an interesting measure, lifespan disparity, to measure the concentration of the ages at death. And we have seen, after looking at the trends over time in the average, the mean life expectancy, how the variation has been going down and become narrower in recent years. So we see life expectancy is increasing and lifespan disparity is decreasing at the same time. Another reason to say what we see in terms of survival and longevity has been a success story. And let's continue in our next lesson. It's rather called a case study. What happens if something not so beneficial is happening, specifically the COVID-19 pandemic, and what I think will be the long-lasting impact of the pandemic on longevity. Thank you very much, and I would be delighted to see you again in lesson 5. Thanks.